Good morning, students. Today we are going to study the last section of this chapter, triangles. The section is Pythagoras theorem and its applications. In this section, you are going to study 3 theorems. In that first, that is theorem number 6.7 is the first theorem. Statement is like this. If a perpendicular is drawn from the vertex of a right angle of a right triangle to the hypotenuse, then a right triangle on both sides of the perpendicular are similar to the whole triangle and to each other. Here ABC, see here, this is ABC as a right triangle, and BD is that perpendicular drawn from that vertex B, that angle B is 90 degree. If you draw like this, if you draw a perpendicular from this vertex B to that hypotenuse, then you see here in this figure, you see 3 triangles. That is in the perpendicular, both sides. So you can see one triangle. That is one triangle here. That is ADB, and the another triangle here. That is BDC. And also the total triangle ABC. See here 3 triangles. So that then the right triangle on both sides of the perpendiculars. Both sides of the perpendicular, that is one is ADB, another is BDC. These 2 triangles are similar to the whole triangle. Whole triangle, which is the whole triangle here, that is the big triangle ABD. So ADB is similar to ABC, big triangle. See, again, the right side triangle, that is BDC. That BDC is also similar to ABC. And in the last part of that theorem, and to each other. What is meant by that? And to each other. That means that 2 triangles on the left side and right side of that perpendicular 2 triangles are there, no? That 2 triangles also similar to each other. That is ADB is similar to BDC. So these are the 3 cases, similarity conditions you are getting if a perpendicular is drawn from the vertex of a right angle to the hypotenuse. So this is a theorem. We have to use this theorem to prove the Pythagoras theorem. Pythagoras theorem, that is theorem number 6.8. In a right triangle, the square of hypotenuse is equal to the sum of the squares of other 2 sides. That is a theorem. It is in a right triangle. Here it is if. So in a right triangle, this right triangle, what are the things given here? We need the proof of this theorem. That is in the syllabus. Okay. So you have to study the theorem statement as well as proof. In a right triangle, here the right triangle, what is given? A triangle ABC. This is a triangle ABC is given. That is our right triangle. And AC square, right angle at B, we have to prove that AC square equal to AB square plus BC square. For proving that, one construction is there, that you have to draw a BD, that is a perpendicular one to draw from that vertex B to that hypotenuse AC. Draw BD perpendicular AC. We need to apply the theorem number 6.7 to prove this theorem. That is, using theorem, you have to prove this the theorem, a Pythagoras theorem. What is theorem number 6.7? If a perpendicular is drawn from the vertex of a right angle to the hypotenuse, then the triangle on both sides of the perpendicular are similar to whole triangle as well as to each other. So we are going to consider here these 3 triangles, no? ADB as well as BDC as well as ABC. So these 3 are similar to each other, no? So we are going to consider here ADB and ABC. ADB and ADC. Here we are to, first you have to consider ADB similar to ABC. You know that if the 2 triangles are similar, its corresponding sides are in the same ratio. That is here, since the sides of the similar triangles are in the same ratio, we can write AD by AB equal to AB by AC. Then cross multiplying will get that AD into AC. Then when you are doing this cross multiplication, we'll get that like this cross multiplication, AD into AC equal to AB into AB. AB into AB can write as AB square. One more case want to consider for proving this, that is the next triangle, that is this triangle ADC, this triangle BDC as well as the big triangle ABC. So BDC is similar to ABC, that we know. Then since these two triangles are similar, then we can get two ratios, that is CD by BC equal to this ratio, CD by BC equal to BC by AC. We have to select that ratios to get a BC square. Here AB square. In the first case, we need to get an AB square. Second case, we need to get an AC square. Like that, you have to select that ratios. After that, two cases we get adding 1 and 2. Adding 1 and 2 means, so this is a 1. This is equation number 1 is this, and equation number 2 is this. Cross multiplying CD into AC equal to BC square. So adding 1 and 2, AD into AC equal to AD into AC plus CD into AC equal to AB square plus BC square. We get that. Okay. Then from that first left side which is common there, AC is common. Here one AC is there, here also AC is there. That common you are taking outside, and what is getting remaining as AD plus CD in the left side. Okay. Then in the right side, AB square plus BC square itself. Then in the next step, AC into AD plus CD. AD plus CD. AD plus CD, what you can write? AC. So AC into AC. So in the left side now it become AC into AC. So AC into AC is AC square. And the right side, what is there? Right side AC into AB square plus BC square. So AC square equal to AB square plus BC square. This is the proof of the Pythagoras theorem. One more theorem is there, that is theorem number 6.9. That theorem is converse of Pythagoras theorem. Converse of Pythagoras theorem. How can we tell that converse? Converse means that in a triangle, if the square of one side is equal to the sum of the squares of other two sides, then the angles opposite to the first side is a right angle. There it is given right triangle. Here you have to prove right angle. So here what is given here, ABC is that ABC is a triangle, and in which that relation, that is AC square equal to AB square plus BC square is satisfied, and then if we satisfy this, then that angle B will be a 90 degree. That means the angle B is a right triangle. This is the converse of Pythagoras theorem. The statement only want to study. Proof no need to study. That is a deleted topic. So just want to know the statement of this theorem only. Now we can move to the exercise questions.